I would like to invite you to come back on the surface where architecture is happening and which is also the origin of our next speaker, so to say. I would like to briefly introduce Ludger Hovestadt to you. He is an architect, an academic, a researcher, an author, a theorist, and also co-founder of companies and startups and many more. He has not only published canonical texts and books in the field of digital architecture, but is of course also a well-invited speaker and lecturer and keynote speaker around the globe. He origins from Germany, has studied in Aachen and Vienna at the masterclass of Wilhelm Holzbauer, as I learned lately. Then he started his academic career as a scientific employee and assistant to Professor Fritz Haller, and since 2000 he is professor at the ETH Zürich and is leading the Institute for Computer-Aided Architectural Design. In his work he is following a quite unique interdisciplinary approach, bringing together architecture, informatics, mechanical engineering, robotics, as well as cognitive psychology. And in his research, he is studying together with his team fields like generative design, digital production, building intelligence. And lately, he was coining a term called digital architectonics, which is also the name of the lecture today. As such, I'm super excited to listen.
Thank you so much for the introduction. Thanks for the invitation. I want to give you a talk which is quite different from what you heard today. And I want to give you an idea of what I think as an architect computers are and where the challenges are for architects. And so I started with computing in 74, so I'm a dinosaur in these things and had a lot of development. And I will give you a short, I think that's the interesting thing. I will not show fancy pictures of projects we did. I will tell you the story, how these things merged and what the current questions are for me as an architect, knowing a lot of computers. So the most astonishing thing is that even I started with the chair from Computer-Aided Architectural Design in Zurich. Computer graphics, I find it very suspicious. In principle, I don't like it as an architect. And this is, and the more I understand, the more it is like that. And the astonishing thing is, maybe this, that as an architect, you are really shocked if you understand that you can't see space. Space is transparent, is void. You can see it. It's of light. Things in space are, all the light waves, they collide. They don't collide, they are omnipresent. And it's synchronous around the world in light speed. This is what space is. And you can see it. What you see is matter. It's of gravity, which is not light. Light is not of gravity. And there are only these two. And what we see is matter. So this is with reason, with cause and effect. This is exclusive, it's of gravity, and I can see it. Space, not. Space is omnipresent, it's transparent, and I can see it. What I would say, I can hear it. So the more I see, for example, with all these pictures around, there's this flood of images. And the more images we have, the less value they have. And we are really occupied with it. And we get blind with images. So, for example, it's very complicated to explain students how to behave if they're 5 or 50, I don't know. If they're 500 million, it doesn't matter. Yeah? Good architectural photos a day extra, new. What to do with it? And the key problem with these images is that you have to look at them one by one. They are like bricks. One. You really have to touch them. There's no way to get a summary or something. But, and that's the interesting thing is, you can talk about them, as I'm doing, without showing any picture. I can talk about 5 billion pictures within 2 seconds. Fantastic. Therefore, I would say that the key moment, and that's very surprising for architect, is it's auditive. Architecture is a public talk. It's not visual in the first stance. So this is to computer graphic people, or me as an educated architect who learned drawing. It's an art school here and so on. I had to meet this exam, to get accepted and so on. All this is interesting because, especially now with all these techniques, architecture seems to fade away. So we can't grasp the things any longer with all these colorful pictures in higher and higher resolutions, more and more colors, and this huge amount. The way out is architecture is a public talk. So, or for example, and so it's very obvious if you start to think about it. Or how do these mobile phones work? How is it possible that I have a phone and I'm able to talk to China or to Mali instantly? So the first thing is, if I talk here, this is of gravity with my voice. This is real. This thing transfers it into space, into light. It goes electromagnetic through the cables or to the air. It's electromagnetic. It's not visible. It's not physical. You can't touch it. It's synchronous on the whole world. It's light speed. Instantly everywhere. Space is full of all these talks. Interestingly, I can still see you. The space is full of all the mobile talks and all the videos. Just full. And then I take another of these devices and it takes it and makes it physical again. But turns it to matter. This is why it works. So simple. And I think it would be so simple to love these stories, but we don't telling them. It's a little sad, because so beautiful. So I would like to relativize computer graphics. Or get what is the key of architecture, or architectonics better. So it's the art of joining things. So I started, and now I give you how this turned out that I'm getting fascinated in these things. So I started at ETH in 2000. And I would say these are 3 phases of experiencing and so on. I started with a very generous contract, so which is unique, a unique challenge. I just tell you this because that you get the taste of it. So it's about. I was able to have a research group with about 16. I still have it, 16 PhD students, and I don't have to ask for money in this size since 2000. So, which is extremely generous, but it's unique. So I was faced with a situation, first, that this is unique. So it's very complicated. It turned out to be almost impossible to find colleagues in a similar situation and to talk about these things I want to do. But on the other hand, as an architect, even with this apparatus, you have no chance in competition with the big firms and companies. So what is in gaming industry, in computer graphics, augmented reality, virtual reality, and so on. These big companies, if you go there with these big fairs and conferences on computer graphics, 20,000, 30,000 people, and so on. In architecture, in computer graphics, in total, serious researchers, I don't think there are more than 400. So this is 1/10 of what Trimble has as developers. So therefore, it was a situation that me as an architect, seeing all this development fast, fascinated by that, and I felt like this is on a highway, so they're just driving like on a highway with high speed on a German motorway. And you stay there, and you're with your tractor, huh? And trying to keep up. So this was the situation. So on one hand, you have a nice tractor in comparison to your neighbor with the other tractors. So a little bigger, more horsepowers, newer. But it's still a tractor. Yeah? And there are all these Mercedes and Ferraris, and so they're on the highway. So, therefore, we decided in the beginning not to compete with the technical development itself. So we tried to understand with our potential what is going on and transfer it to our architectural domain. We never had any interest in developing IT techniques itself. We always tried to get applications for that. So just to give you a profile how these things developed. So this was complicated to reflect in my scientific community. So, and therefore we simply said, if this should be successful, we have to prove it by founding companies working on market. So therefore, in the first 10 years, I founded some 6 companies, 5 of them still working, so that's some 250 people working there. I'm out of all the business. So this is okay, it's not super, but so it's not nothing. But we scanned, so we had been scouts, and we scanned what can be done, and tried to implement that. The interesting thing is, for example, that things around parametric design, things about digital fabrication and so on, no chance to sell it. These prominent things in research, there was no chance to apply it and get sufficient money for that in companies. So I pretend to, I'd like to say that we pioneered a lot of these things, and then we tried to sell, and there was no way to do. Other things worked quite well and smooth, unexpectedly. The most stupid thing after, I don't know, 6 years of research in complicated constellations on the Internet of Things, on And these things was, and smart buildings was at the end a tracker, a sensor, a tracker, sensing motion, GPS, temperature, equipped with a solar panel, wrapped in a brick size with a big magnet to track containers on the sea across the world to know where they are. So this is a device which costs nothing. So this is what kids in school with 14 are able to do with Arduino. Very frustrating for an engineer. So that's the first thing. Getting it down from all this research to a proper application. This application was make it ruggable, plug it to a container and sell. And the key argument was not it was for 20, 30 euros to produce, not sell it for 100 euros, but sell it for €1 a day. Then they come and say, okay, that's it. Very successful. Very frustrating. So it's a complicated story. Then you go with parametric design, with these shapes and with this milling and getting this geometry, go into production, go into factories and so on, make it perfect and so on. In Innsbruck we made these Hadid ski stations, the geometry for that. No way to earn money with this in a reasonable way. This, for example, it's a very, very striking experience. So this was the first phase, and it ended in my perception with, we succeeded in the fully automatic design with AI. My background is always AI, not computer graphics. We ended up in a machine which was able to generate a building block with shops, apartments, doctors, so offices and so on, a hybrid block, a building block in the city of Zürich. Fully automatic design, and we won a prize. And we didn't say that. This was 2008, I think. And we didn't say that. And then, of course, we had been proud that we were able to do and win the kind of Turing test for that with that. But the shocking thing was, again, we couldn't sell it. Nobody liked it. Not the students, not my colleagues, not the investor, not the real estate manager. Nobody liked it. They always hated it because they had been afraid of burning their brand, because it's not with people and not understanding, not emotional, and so on. If you argue like this, it might be a different story today. But we had to decide either to go underground and make it 200 times a year without saying, or simply, and this is what we did. We made a step back and asked, what is it if computers can do what we think architecture is? What is architecture then? And this was the second phase. We started to think about in a very substantial way. We skipped the empirical things, and this was around 2010. And then we reasoned about in a very substantial way. We went to principal mathematics, the principal understanding of AI techniques. We went to philosophy, architectural theory, and wrote a couple of books. I can show you. So it's quite a lot. These are books we published. These books, so with this kind of research, that you make this step back and you think, you reason about what the hell is going on. we came to these very strange setups. Yeah? That I told you what is space, or what is time, or what is matter, what is light, what is architecture then? And especially we got respect with the old guys. So it's the guys around Vitruvius in antiquity, or the Alberti in Renaissance, had exactly the same challenge as we have today with in the perspective drawing, for example, in the upcoming of the perspective drawing with Alberti, as we have today with augmented reality, virtual reality, with big data, and so on. It's exactly the library and the big data. So what is memory, and so on. Exactly the same problems all around. So which is fantastic. So you can see, analyze what the situation today is, go nicely abstract, and then you see that there are similar constellations in thinking in the older time, in certain older times, which resonate, and you learn by symmetries. Very nice. So, which means now the third phase is that we are kind of under, I think it gets very stable how to talk about computing today, how to talk about what AI is. For example, AI, I strongly believe, despite all these excitement around these thousands of different specialized algorithms, it's just one single phenomenon. It's all the same. The interesting so again, in these symmetries, I would say it's just on the quantum level of quantum physics, the same like on the classical physics with Newton or with Descartes was the differential. The differential calculus is exactly what we have with AI today on quantum level. Just putting two things in difference. So for example, how does it work with translating Chinese, English? You have a lot of books, and in English you have a lot of books in Chinese. A perfect would be if they're all the same. And you simply say, on an algebraic way, A equals B. They're the same. And then all these networks make it the same in these curved, complex planes. And you put any sentence in English and you get a Chinese one. And it's reasonable. This is exactly the same like car driving. You have you have all the sensors, you have the actuators, then you drive good, and you say sensors and actuators in millions of events, the same, algebraic the same, and then these things get morphed, and whatever the sensors are, these things know how to drive good. That's a phenomena. That's a differential between things, whatever it is, which is interesting. Because you don't know, and this is working just because you gave up to reason about what it is. Which is threatening for engineering, and absolutely fantastic for architects. Therefore, I'm an architect, I can say that. So I give up every reason and simply say these things are the same. And for example, if this is of reality, this is of reality, then you say the same and you cross out reality. It simply doesn't matter, whatever it is. It's pure rational difference of things put together as same and you operate with it. And there's no reason, means no reality, no reason, no origin, no argument, it just works. And you can look it up. There's another line here with our projects and research. We went everywhere, in a lot of applications. We went in wineries, we went in branding, we went in traffic, so you can go, it's always the same. Just take data, as much as you get. It doesn't need to be curated, dirty, incomplete, just take data as much as you get. That's a key problem to get today, because they're covered by companies. Encode them, put things the same, decode it, and you're there. And it doesn't matter. Take 5,000 or 50,000 floor plans of an architect. You say, perimeter of the building, entrance, floor plan, perimeter, floor plan, perimeter, floor plan. You say, this is the same. Take any perimeter, you get a floor plan. And you don't need any more reason for it. It's fantastic. So this kind of thinking we had been able to do and put it in these radical terms, digestible for architects. And now for 3 years, around 3 years, it's about, if it is like that, we are living in a world, in the web of things, where space gets another kind of scalarity. Things get connected in a new way. If there is, the space is now full with images. It's full with everything, what we know with internet. What is architecture then? How does these things look at this? It's a space, and it resonates, and for that it has this rhythmicality. So the architecture is rhythmicality, there's a proportionality here. It's not the matter. So it sounds, it resonates. So imagine now space globally full with everything we hate, we love in internet. It's just full of it. How to get these resonances? What resonances? How do things show up? So now we are starting to establish a didactic using a lot of books, a lot of movies, a lot of images, a lot of architectural models, a lot of textures, not a lot, really a lot, thousands, 10,000s, to be able to do architecture which is adequate and the speed and connected of today. This is what we are currently, our interest is. So, and I think this story I wanted to tell. I think it was important that I didn't show you any picture because it's about words, about these stories. And I think you get an idea of how this turns in my 30, 40 years in computing worked out. And of course it will turn on. But I think it's symptomatic of what to expect, because I'm very research-driven and very curious and strong and pushing these things. But I think this turn I'm telling you, it's an indicator, it's symptomatic what to expect in the next coming time. So this should be my talk. Thank you for listening.
Yeah, thank you for your lecture. Now, are there any questions? Or comments, maybe? Or disagreements, maybe?
Yes, thank you for the presentation. I have a question, because you were talking about the adequate architecture. Which would be resulting. Do you have examples of this adequate architecture, or can you indicate what would that be?
Okay, this is missing in my talk. Good question. So, what I think, this turn of technology, this is not a recent phenomenon with the internet and so on, and computing. So what it changed around 1880, 1920, I'm pretty sure, when quantum physics came up, the corresponding mathematics. All the principles in thinking of what I'm telling you is 100 years old. So therefore, if I'm talking about artificial intelligence like I did on a quantum level, or if I talk about computing and so on, this is 100-year-old thinking. So this is a body of thinking, we call it, which is 100 years old. What happened in these 100 years is that these things got secularized, available, technically available, and it's just there with all these tools. It was not there, but intellectually it was there. So intellectually these things didn't develop the last 100 years, but technically. So it's available everywhere, globally, and everybody likes it or hates it, but nobody can escape. Nothing can escape. If it is like that, it's very radical. The first thing is AI, there's nothing of relevance in the 20th century which is not AI. So we can discuss that. So that's important. That's not a recent phenomenon. So it's 100, 120 years old. And if you ask for architects, there's no masterpiece in architect of the last 100, 120 years which is not organized in the way I talk. We're simply not able to see it. That's the key problem. So my hypothesis would be because we had pictures of them. Because with that we get blind. And if you start reading, for example, Corbusier or the constructivists, the Russian suprematists, and so on, if you read them without pictures, it's my talk. Interesting.
Somebody else? Maybe? Michael?
Yeah, I do like computer graphics, obviously, but I was wondering about space, because you cannot maybe see it, but you can perceive it by the boundaries of the space.
Yeah.
If you see this room, you don't see the space, but you see the boundary, so you know the space is what's bounded. Yes.
Yeah, you see
so
the material.
I don't see the big problem with not being able to see it, because you can still understand and perceive it.
Yeah, but this is not a space, these are the beams, and this is a wall, it's not a space.
Yeah, but where's the problem in that?
It's not a space, and as an architect I'm organizing space. And what you can see is what you talk. So what I'm telling is not, you can see it. And our world is space and boundaries. So it's what I'm talking and what I'm showing. The same with my body. So it's in sync with the harmonic things, and it's present in my gravitational thing as material. And I'm vivid because these things are in proportion, more or less. And if you skip the space, the vivid, then these things are dead. This is dead. If you skip talking. And if you skip the materiality, these are ghosts, it's nothing. But it's vivid if these things are in proportion. And if you have that, then it's all our philosophy since ever things had been written all the time. So it's not new, not a super original insight I gave. It's just astonishing that we get shocked, same with me, shocked that you can't see space. Yeah.
So I don't agree with the saying a picture says more than 1,000 words.
Pardon?
I don't agree with the saying a picture says more than 1,000 words.
Yeah, of course, you can say that. But the word,
Many people
the
believe in
word
that.
contains more than 1,000 pictures. So, yeah, and this is again these things need to be in proportion. So, without gravity, the things are dead. They are ghosts, and without light, they are dead. So you need these proportions. So, and therefore 1 to 1,000, also this is a bad proportion. So it's not harmonic. So if you need a proportion 2 to 3, 3 to 4, so like playing a piano. So you have certain proportions in how these things work. And this is with words and with pictures have to be in proportion like this. Or my strong hypothesis would be, for example, if you go to tradition with architecture, then ethnography, so the floor plans, they sound. They're empty, and they sound, whereas the walls are massive, and they are of silence. The space is a vacuum, the floor plan is a vacuum, and the wall is silent. And both are this is scenography in proportion to make a building in human scale. And human proportion. So that's what Leonardo did with his Vitruvian Man, and so all these stories around these things. Proportioning this.
I would also have a question regarding the teaching that you do at the ETH, because I was once lucky to see your studios work of your students, and I think I kind of got a glimpse of the method that you might be using for them to produce or to use AI in order to create, I would say, rather a flow of imagination. And having that in the background, what you produce at the ETH in your studio and what now seems to be this new mid-journey twist in architectural education. So, I mean, I don't know if you've observed that. A little anecdote maybe is there was a little panel discussion lately by teachers across America and also European, and some of them very, very renowned, and they were all talking about how to use mid-journey now, and it seemed to be that it would be really, and now we let students do the classical perspective, the elevation, the ground plan, and then how do we interpret it, and how do you see that? Because it seems that a mid-journey is now such a, or DALL-E is such a powerful tool, and what will it do with our imagination of architects?
Yeah, acoustic here is very, very bad. So I think I got it. So, yeah, what to argue in a bold way. So, what we're using AI for is not for solving any problem. So the key problem of architecture is we have to forget about solving problem and understanding people. So that's important. So, therefore, we don't use AI in any problem solving. So what we are using it, if you make a bold metaphor for it, we're using it as a super extended mood board. So instead of having 100 pictures, we have 10,000. And are able to manage it in a fast way. So we have mood boards. We have, in principle, 2. So one is the first module is for ichnographia. These are 1,500 books about architecture. This is about text, because I told you the space is talking. It's talkative. It's a talk. So it's kind of the whisper of what should happen here now in this Kuppelsaal. So we use AI to access these books and be able to work with them in a poetic way without having read them. And it works beautifully. Fantastic. So it's a kind of private Google what we are doing. So we just collect books in our private library, and then we are able to use the algorithms of Google just with our library, and by that, it's not corrupted by any other intention, and we are proud of our biases having nice architectural books. So we don't fight biases. in AI. So it's the first module, writing a text about the rooms and about the building, talking, and so on, going around. And loading this design with text, with talkings. Second module is the same thing, it's just with images. We have 1,500 movies, some 3 million keyframes. This is accessible, we can search with text to image, with image to image, image to movie, and so on. But this is not the text, so it's not the floor plan, this is the orthographia, this is the, these are the walls. And again, it's full, it's a lot. So, second module. And the third module is bringing that into a human proportion. So the talks and the images into a human proportion, which is a perspective, it corresponds to the perspective drawing, the mechanics of the perspective drawing. Here again, this is the first time what we are doing now, is we use AI to get kind of passepartouts or formats of 3D models which might work to get certain constellations easily done. The key problem what we have is that our studio is only 12 weeks and it has to be extremely didactic. So in the moment we start to reflect on what we are doing on this complex level, we are lost. So it's extreme didactic. And it's performing quite well, so we're quite happy. And now the third module gets AI support as well. But you see, we have floor plan, we have the Aufriss, the orthographia, bring that in proportion as a model, which as a rhetoric gesture, so it's not geometric. It's just bringing these things onto human scale. Ichnographia, orthographia are global. Bringing that to the human scale of the customers. And if we have that in proportion, we render it, for example, in geometry or in pictures. It's just a rendering, and it's rhetoric to sell it. It's not the architecture. This is how it works. You can look, it's called Meteora. And everything is, these are the studios, student work, everything's on Instagram, the whole process of each project we had. We are not quite there, that these are actual buildings, but I think it's on a good track. So we can't be too pushy because we don't want to be exclusive, so it has to be inclusive. We want to embrace global problems. We don't want to exclude certain things with pragmatics, with problem solvers. So we want to go around all these problems. We just want to embrace everything and shape it and temper it in the student's way. What is very nice is, in contrast, so it's the first time I'm able to teach in computing where computer is not just gaining speed and precision by narrowing things down. It's really opening up. It's absolutely fantastic what students are able to do in which spectrality of things. That's of an enormous beauty. I'm proud of it.
So I have maybe one question here, more concrete. So you said you got 16 positions with your professorship, right? So what? Did I understand this correctly? You said you went to ETH and then you got 16...
It's PhD positions, yeah.
6 or 16?
16.
16.
Yeah, so
Yes.
huge apparatus.
16 PhD positions.
Without asking.
And you'd still have them, you said. So
Now I have only 12, I had to complain.
Okay, poor. So what tasks do you give them? What do they do? What is their... So
They work in this spectrality. So I don't argue a problem. So it's a group of no, I try to select them in a way and so that we can share a common interest in this kind of questioning computing in architecture, or computer might be. And by that, this takes long. So we never have 3 years PhDs, always 5, 6 years. But we share that, and then they get strong personalities in these things. So it's never, we don't solve any problem. And yeah, a lot of them don't succeed to grasp things so that they can finish with PhD. But that's the game. And by that it stays open. That's very interesting. I could afford this as a luxury from all this luxury setup.
Yeah, if there are any further questions, otherwise, is there somebody? Otherwise, I would say, Michael, are you doing some closing words? Yeah. Thanks a lot again, also for the question and answers.